Welcome to Lesson 10, Autoscaling, where the cluster finally starts paying for itself. Static sizing is the quiet budget killer in Kubernetes. You provision for peak and pay around the clock for capacity you use a few hours a day. Over the next 12 slides, we'll build a 4-tool mental model, HPA, VPA, Cluster Autoscaler, and KEDA, and see how they combine to deliver cost and performance at the same time without manual intervention. Here's the shape of the lesson. We'll work the SRE loop end-to-end. First, observe the 3 layers where scaling happens: pods replicas with HPA, pod resources with VPA, and cluster nodes with Cluster Autoscaler or Karpenter. Then diagnose with kubectl top and describe to separate saturation from waste. Act by picking the right combo for each workload type, web, batch, or stateful. And finally, document the policy, because an autoscaler without MN, max, PDBs, and cooldowns is just a surprise bill waiting to happen. So let's meet the 4 tools. HPA adds and removes pod replicas based on CPU, memory, or custom metrics. It's the one most teams reach for first. VPA right-sizes the requests on those pods, killing chronic over-provisioning, but pair it with HPA carefully, or they'll fight. Cluster Autoscaler, or Karpenter, the modern alternative, adds nodes when pods go pending and removes them when underused. And KEDA layers on top, scaling on event sources like Kafka or SQS, with the superpower of true scale to zero. Different problems, different tools, combined, they give you real elasticity. Starting with HPA, the workhorse. The loop is simple. Every 15 seconds it polls metrics, compares actual load to your target, and adjusts replica count on the deployment. CPU utilization is the default knob, but real elasticity comes from custom metrics. Here, requests per second per pod, which tracks user demand far better than CPU ever will. 2 guardrails matter. Min replicas keeps you above cold start territory, max replicas caps the bill, and the behavior block is non-negotiable in production. Scale up fast, scale down slow, or you'll thrash through every traffic dip. HPA handles replica count, but it can't fix a pod that was sized wrong from day 1. That's VPA's job. 3 modes to know. Off just gives you recommendations, initial applies them at pod creation, and auto restarts pods to resize them on the fly. Critical pitfall: never run VPA, auto, and HPA on the same metric. They'll fight each other into oblivion. Cluster Autoscaler works 1 layer down. When pods go pending for lack of capacity, it asks the cloud provider for more nodes and trims nodes that sit underused for 10 minutes. Karpenter is the modern replacement. No node groups, picks the right instance per pod, scales in about 30 seconds. Here's the gap. None of those 3 close. HPA can't scale to 0 because a running pod's CPU never actually hits 0%. KEDA fills that gap by bridging real event sources into the HPA machinery. In this scaled object, min replica count 0 means the consumer deployment disappears entirely when the Kafka topic is quiet and spins back up the moment lag crosses 100 messages. 60+ built-in scalers ship out of the box: SQS, RabbitMQ, Redis, Postgres, even cron and raw HTTP. So almost any queue or signal you already have can drive replica count directly. Individually, each tool leaves money on the table. Combinations are where the real wins live. For typical web and API services, pair HPA with Cluster Autoscaler. Pods scale on CPU, nodes follow underneath, and a 10-minute scale-down stabilization keeps you from thrashing. For batch and event-driven workers, KEDA plus CA gets you to actual 0. No pods, no nodes, near 0 cost during quiet hours, often 50 to 90% cheaper than always on. And for stateful tiers, skip autoscaling. Run VPA in off mode for recommendations, then right-size manually each quarter. Once you've picked your combinations, 6 habits separate teams that merely have HPA from teams running a genuinely cost-optimized cluster. Set requests and limits first. Without them, HPA silently does nothing because utilization math needs a denominator. Add stabilization windows so a single traffic blip doesn't trigger a scale-up, scale-down loop. 0 seconds up, 5 minutes down. Put a pod disruption budget on every auto-scaled workload so Cluster Autoscaler drains nodes gracefully instead of evicting all replicas at once. On cloud, prefer Karpenter over Cluster Autoscaler, 30-second scale-up versus 3 minutes, and it picks instance types per pod. Use KEDA for batch to scale to actual 0. And when something goes wrong, Kubectl describe HPA tells you exactly which decision it made and why. Here's the whole lesson on one page. 12 patterns, 4 columns of muscle memory, Kubectl Autoscale for a quick HPA. Watch it live, and remember V2 is the current API. Tune behavior scale down. Hold min replicas at 2 to dodge cold starts, and pick a VPA mode deliberately. Reach for Cluster Autoscaler or Karpenter for nodes, KEDA for event-driven and scale to 0, and always pair workloads with a PDB. When something misbehaves, describe HPA tells you why. Now the failure modes, 5 pitfalls common enough to have names. 1. An HPA with no resource requests is silently disabled because utilization divides by 0. 2. VPA, auto, and HPA on the same metric will fight each other forever. Split them or use VPA initial. 3. Skip the stabilization window and a 30-second dip triggers a thrash cycle of 502s. 4. Cluster Autoscaler without a PDB will happily drain your last replica. And 5. 1,000 replica max replicas looks harmless until a bad metric hands you a $5,000 hour. Cost caps beat theoretical capacity every time. Theory hardens into instinct through 3 exercises. First, on a kind cluster, install metrics server, autoscale an NGINX deployment, and hammer it with a busybox loop. Watch the HPA's current and target columns shift in real time. Second, install VPA in off mode against an over-provisioned app, wait 10 minutes, and read the recommendation, usually a 90% capacity win, no restarts required. Third, install KEDA. Point a scaled object at a queue with min replica count 0, and watch pods materialize from nothing when messages arrive, then drain back to 0. That last one is what paying nothing for idle actually looks like. And that's lesson 10 in the bag. Your cluster is now elastic. HPA handles the workhorse scaling, VPA right-sizes the requests, Cluster Autoscaler and Karpenter grow the nodes, and KEDA takes you all the way to 0. Next up, production hardening and multi-cluster, pod security admission, network policy, secrets management, and fleet operations, because an elastic cluster still needs to be a locked-down one. See you in Lesson 11.